Okay, guys. So today I'm recording the video from the last section. This is the lecture from section 2.5. So I will be going back and forth because we're going to solve the word problems. And the topic of section 2.5 it's about variation. So you have this PowerPoint uploaded. However, I'm going to use whiteboard to solve the problems. So in section 2.5, we're going to talk about construct model using direct variation. Then we'll talk about solving the problems using inverse variation. And then we'll talk about joint variation and combined variation. Okay. So first, we'll start with the direct variation. Okay, so I'm going to give you the definition of direct variation, but also I will write this down. So we're going to start with direct variation. You guys have that definition on the PowerPoint. Okay, but let me just write this down. Okay, so first we're going to talk about direct variation. So direct variation, this is like proportional, okay? The formula is y equal k times x, okay? And what is important, that k, it's always constant. We call it constant of proportionality. And you always k, it again, that direct variation will be something like y equal 3x. You always need to know what is k. So you always have to find k. You need to know what is the constant of proportionality. Y and x are your variables. So let me just write note. Y and x are the variables. So example of direct variation, and also before I will give you the example, you read this as y is directly proportional to x. So we read that as y is directly proportional to x. And this is important because we're going to have three different types of variation. And you guys you will know with which type of that variation we dealing with based on the words which they're using in the problem. So directly proportional, that means the equation which we need, it's y, it's equal k times x, where k, it's the constant of proportionality. Okay, so I will go back to the PowerPoint. Okay, so let me show you how the graph of direct variation looks like. The equation, it's y is equal k times x. Okay, so you have a straight line starting from the origin, and the constant of proportionality has to be positive. Okay, so we're talking about direct variation. So this is how the graph of direct variation looks like. Straight line, you even may think that that k, it has the same meaning as a slope, which technically, yes, it's true. Okay. So what I'm going to do with you guys, I'm going to solve the problem from your textbook. This is problem number 5 from page 191. And in this problem, I want you to write a general formula that describes each variation. So here we have that y varies directly with x, and we have given information that y is equal to and x is equal 10. So let's solve this problem. So again, first we're going to solve number 5. Number 5, from your textbook, this is on page 191. Okay, and let me just try to copy and paste. Hold on, guys. Go down to the PowerPoint. Let's see if I can copy this. Not sure. No. There's no way that allow me to copy. Okay. So hopefully you guys see that problem. Okay. So let me just rewrite it. Y varies directly with x. And this is the given information. We know that x is equal to 10 and y is equal to. Okay, so this is the key. We know that y varies directly with x. So I'm going to write the formula of direct variation, which is right here. Y is equal k times x. So use formula y is equal k times x. And for direct variation, the only variables which we should have, it should be y and x. K, we need to know what is k. So next, what you need to do, find k, which is the constant of proportionality, by substituting by substituting 10 for x and 2 for y. Okay, so this is the direct variation formula. We're going to replace y with 2. We need to find k, and we're going to replace x with 10. So solve for k, we're going to divide both sides by 10, and we're getting that k is equal to 2 over 10, which is the same as 1 over 5. So 1 over 5, it's our constant of proportionality. You always need to find it. K should not be your variable. So the formula is y is equal 1/5 x. So this is the equation of the direct variation. Okay, so like you see that k, you always need to find it. Next, what I'm going to do, I'm going to solve the problem. And you know what, guys, I will log into ebooks, so it will be easier for me to copy those problems than from the PowerPoint. So you guys, next what I want to do with you, so I'm follow the PowerPoint. So we're going to solve number 23 from a textbook. However, you guys have this problem on the PowerPoint. In my case, there's no way that I can copy that and paste, so let me just open the textbook. So let me pause. So I tried to copy that, but it For some reason, I have a hard time. Um, so here, guys, we're going to solve the problem from your textbook, and also it's on the PowerPoint. This is number 23 about the mortgage. So mortgage payment. The monthly payment P on the mortgage varies directly with the amount borrowed B. So we have two variables, P and B. And I know that we're dealing with direct variation because of the word directly. And so the equation will be P is equal K times B, where K is a constant. So we also always need to find that K constant. So to find the constant of proportionality, we're going to use the second sentence. So if the monthly payment on 30-year mortgage is $6.49 for every 1,000 borrow, so we're going to use that information that if we borrow 1,000, we're paying $6.49. So from those information, we will be able to find the constant of proportionality. Find the linear equation that relates the monthly payment P to the amount borrowed B. So the equation will be P is equal K, which is constant times B. We need to find that K. And then if we build that equation, we're going to find the monthly payment when amount which we borrow, it's 145,000. So you guys have this problem, and let me just go back and just write all the information which we needed. Okay. Okay. So the next problem, it's from your textbook. It's number 23, page 192. Okay. So we have two variables. P represents monthly payment, and B represents the amount we borrow, money borrow. Okay. Now, we know in this problem that the monthly payment P on the mortgage varies directly with the amount borrowed B. So I know already how to create the equation. So that means P equal constant. You're always going to have a constant times B. So again, don't forget that K means constant of proportionality. And we need to find K using info from the problem. Okay, so that K, you can only have two variables in direct variation. So we have P and B. K, it's a constant, we need to find it. So how are we going to find it? Okay, they telling you in the problem that you paying $6.49 for if you borrow 1,000. So I'm going to use that information. So use info that if we borrow 1,000, our monthly payment will be $6.49 to find K. So I'm going back. So that's going to be our direct variation formula. I'm going to replace P with 649. K, we have to find it, and B is equal 1,000. So we're going to divide each by 1,000 to find constant of proportionality, and we'll end up that k it's equal 0.00649. Okay, so I move decimal place 3 units to the left. Okay, so this is constant of proportionality. So in those problems from section 2.5, you always need to find k. So now our formula will be p payments equal to constant of proportionality, which we already know, which is 0.00649 times b. Okay, so this is your equation, only two variables. K, we always need to find it using given information. Now, when we have the equation, I can answer the question from the problem. So here they asking you, find monthly payment. So find P when the amount which we borrow, it's 145,000. So now we're going to replace B with 145,000 to figure out how much monthly we're going to pay. So now find P if B it's equal 145,000. So how much we monthly going to pay if we borrow 145,000? So payments, it's equal constant of proportionality, which is 0.00649 times B, which is 145,000. Just multiply those two values and we'll end up with 941 and 5 cents. Okay, so that means that the monthly payment is 941 and 5 cents if we borrow 145,000. So the monthly payment is 941 and 5 cents if we borrow 145,000. Okay, so that was the problem 23. This is the real life problem with the application of direct variation. Next, what I want to talk about I want to talk about inverse variation. So different type of variation, it's inverse variation. And we're going to solve some problems with inverse variation. This is the formula of inverse variation. You still have two variables, y and x. So we have y, it's equal constant of proportionality divided by x. So inverse of x. Okay, so inverse variation, read as y varies inversely with x. So again, here k still should be known and represents constant of proportionality. And the same idea, you always need to find that k. Again, k should be positive. And the only variables are y and x. Okay, so k we should know. And we should give the condition that x should be positive. So let me show you. This is the graph of inverse variation. Y varies inversely with x. So y will be positive and x will be positive. Inverse variation. And now I will move on to the example. Okay, and again, inverse variation. So example of inverse variation can be y it's equal 2 over x. So this is the example of inverse variation. Like you see, the constant k, constant proportionality, it's 2, which we always need to know. Okay, so let me move on to the example from PowerPoint. This is the example which I want to talk about it. So I'm going to leave it. You guys have that on PowerPoint. So let's just read it first. Okay. So the maximum weight W, so W will be the first variable that can safely support by a 2-inch by 4 piece of pine varies inversely. So I already know that the formula will be something like y is equal k over x. In our case, y will be w. Because of that information, we have inverse variation with its length. So you have two variables, w and l. They varies inversely. So the formula, just by reading the first sentence, I know that the formula which we need to use will be w is equal k over l. I don't want to know. Okay, so now how are we going to find constant of proportionality? We're going to read the second sentence. So experiments indicate that the maximum weight that a 10-foot long 2 by 4 piece of pine can support 500 pounds. So here we have more information than we needed. Don't forget that our variables are weight. So we know that weight is here 500 pounds. In that way can support the length of 10-foot pine. Okay, so we're going to use that information. Again, that 2 by 4, that's extra info, which you don't really need it. So by using those information, we're going to find K, which is constant of proportionality, and then we're going to answer the question. When we need to find the maximum weight, that safely support the length of 25 feet of the pine. Okay, so inverse variation, two variables, W and L. So let's start with that. Okay, so example, here that's the example. So W represents the maximum weight. L, it's the length. L, it's the length of the pine. Just want to make sure. So this is the length of a pine. And those two variables have an inverse variation. So I'm going to create a formula. So the formula which we'll use to solve this problem will be the inverse variation. We're not going to use y and x. We're going to use w and l. So it's going to be w equal k divided by l. So here we have the only variables which we should have in this problem. Okay, we need to k, it's a constant of proportionality, which we need to find. Okay, so you always have to find that k. So how are we going to find k? Use the info. And going back to the problem, okay, we're going to use that info. That the pine, which is 10 foot long, Okay, so the maximum weight which can support 10-foot long pine, it's 500. So length it's 10, W it's 500. Use that information to find K. So use info that W is equal 500 pounds and length it's equal 10 foot to find K. Okay, so let's replace. So we have 500, it's equal constant, divide by 10. We're going to solve for K. So how you're going to solve it? Just multiply both sides of the equation by 10, because that will cancel, and that will give you that K it's equal 5,000. Okay, so this is our constant of proportionality. Again, remember, those type of problems, you always starting with finding that constant of proportionality. So now the formula which we need to solve this problem is weight equal K, which is 5,000, divided by L. So this is the formula which we're going to use. Weight varies inversely with the length of pine. And let's go back to the problem. Let's see what we need to find. Okay, here, find the maximum weight W, which can support the pine, which is 25 feet long. Okay. So find maximum weight if the length of the pine is equal to 25 feet. So we're going to replace L with 25, and we're having that W it's equal 5,000 divided by 25, and that will give us 200 pounds. Okay, so that's the answer, 200 pounds. So if the pine has a length of 25 feet, that pine can support maximum weight of 200 pounds. So that was that problem using the inverse variation. Okay, so the setting of the problems, the formula of solving all those type of problems is exactly the same. You create the equation, you finding constant of proportionality using second sentence, which gives you that information, and then you can answer the question. Next, what I want to solve it with you guys, it's number 23. Number 33 from your textbook from page 192. So 33 from page 192. And you guys have this problem on the PowerPoint. Here, that's the one. So number 33 from page 192. So let's just read that problem first. Okay. The volume of a gas V. So this is our first variable. Held at the constant temperature in a closed containers varies inversely. So we already know that we're going to have V, it's equal K divided by something because we have inverse variation with its pressure P. So we have two variables, V and P, volume and pressure, they vary inversely. So knowing that, I already have the formula. V, it's equal constant divided by P. So we will have to find the constant by reading the second sentence. If the volume of a gas is 600 cubic centimeters, so we'll replace V with 600, and the pressure is 150 millimeters, we'll replace P with 100, and using that information, you will find K, which is constant of proportionality. When we'll know K, we can solve the problem. Find the volume when the pressure is 200. Okay, so let's start it. So here we have two variables. V will stand for volume of a gas. P will be pressure. Okay. And of course, with those type of problems, we always have that constant of proportionality, which we need to find. Okay. So what we know about two variables, that the varies inversely. It was given in a problem. So we're going to build the formula. V, it's equal constant divided by P. Okay. So we need to find K. We need to find constant. How are we going to find that constant? By using info from the textbook, from the text, that when volume it's equals 600, I'm going to skip the units, guys. Pressure will be 150. Okay, so I'm going back to the text. So you guys see from where I took that. So they give you that information. 90% to the second sentence. If the volume of gas is 600 cubic centimeters, then the pressure is 150 millimeters of mercury. So I'm using that information to find K. So we're going to substitute. We have 600, replace, that's your V, equal constant, which we're going to find, divided by pressure, which is 150. So solve for K by multiplying both sides by the denominator of this fraction, which is 150. That will cancel, and we end up with K, which is constant of proportionality. It's 150 times 600, which will give you 90,000. Okay, so that's the constant of proportionality, which I'm going to plug in right here. So our formula for this problem is V, it's equal 90,000 divided by P. So this is the formula. And now we can answer the problem from the question. Find the volume when the pressure is 200. So 200 millimeters. So we're going to replace P with 200, and that will give us the answer. So we know that the pressure it's equal 200 millimeters. We need to find volume. Okay, so let's find it. So we have V, it's equal 90,000 divided by pressure, which is 200, and that will give us 450 cubic centimeters. And that's the answer. Okay, so hopefully you guys feel all right so far with those problems. There are two more different types of variations, so let me introduce them. Next one will be joint variation. Joint variation, that's the one which have more than two variables. So this one is when a variable quantity Q is proportional to two or more other variables. So joint variation, it's similar like direct variation. The formula has only multiplication, which is product of all the variables. There is no division in joint variation. And of course, we still have K, which is constant of proportionality. Okay, so that's one. And combined variation, that's where you can have a direct and inverse variation combined together. So this one has combination of direct and inverse variation. So here we also can have, so note, we can have more than two variables, and the formula will have both product product, so that's the multiplication comes with from direct variation, division comes from inverse variation, and of course we still have K, which is constant of proportionality. Okay, so I'm going to explain this based on the example which we have on the PowerPoint. Okay, so let's log into the PowerPoint, which you guys have it. And I'm going to talk about the problem from loss of heat through the walls. So let me read it first and explain it. Okay, so the loss of the heat through the wall varies jointly. So varies jointly tells you that we're going to have more than two variables and it's going to be only multiplication, okay, in the formula. So the loss of heat, which I will introduce L for loss of heat, varies jointly with the area of the wall. So that will be A, my second variable, and the difference between the inside and outside temperature. So difference between inside and outside temperature, I will just introduce one variable for that, which will be T. So we already have three variables. Loss of heat equal K, which is constant. Always K, it's at the beginning, constant, times area times T, difference of temperature. How I know it's only multiplication? I gave you in the definition that the jointly means joint variation. You have more than two variables and it's only multiplication in the formula. And look what happened here. Okay, now if we continue, and so that's not the end, varies inversely. So here we're switching to the inverse variation. Inversely means division with the thickness of the wall. So my next variable, which I will need to introduce, it's D, which will be thickness of the wall. So you need to write the equation that relates those quantities. Okay. So let me go back. Okay, so this is that example with the force of the wind. And this is the formula which we're going to use. Loss of heat. So let's just write this down as loss of heat. I'm thinking already about next problem. Loss of heat. Heat example, which you have in the PowerPoint. So the variables which they talk about, L will be loss of heat. A will be area, so that's my second variable. T will be the difference between temperature. Just the different variables for inside temperature, outside temperature. This is just one T. And D will stand for thickness of the wall. Okay. And of course, you always constant. With any type of variation, you always have a constant of proportionality. Please don't forget about that. Okay, so in that problem, they only want you to build the formula. So L equal, let's go back and read it again. Okay, so L, loss of heat, equal, varies inversely. So I'm going to have that K with the area of the wall, which is A, and the difference of temperature. So I have L, it's equal K. K, which is constant, always put that at the beginning, varies inversely with the area and the difference of the temperature. Okay, and don't forget K, it's constant. However, that's not the end. If you continue reading the problem, here that they tell you, and varies inversely. When you see word inversely, that means put the fraction bar with the thickness of the wall. For thickness of the wall, I introduce variable D. So now, because of that and varies inversely, that means it's time to put the fraction bar, that's the varies inversely, with the thickness of the wall. So this is the formula. You can rewrite that as K, move that constant in front of everything. AT, that's that joint variation between area and the difference of temperature, and varies inversely, that's why I put the fraction bar. Inversely means put the fraction bar, thickness of the wall. Okay, so that's the formula for loss of heat. Now, here I just show you how to read the information from the text. Now we're going to do the example force of the wind. Okay, so let me go back to that problem. Okay, force of the wind. This is the example which I will go over. Okay, so let me read it. The force F, first variable, of the wind on the flat surface positioned at the right angle to the direction of the wind varies jointly. That means we're going to have F equal, and we're going to have a multiplication with the area. So in front of everything, I'll put constant K times A, which is area, and the surface and the square of the speed v. So the next variable will be v, but in the formula we have to use the square, which is v to a second power of the wind. So we're going to, before I continue reading, I'm going to use the first sentence to build the formula for these problems. Okay, so here we only have one type of the variation, jointly variation. I know F, force of the wind, varies jointly with area and the square of the speed of the wind. Okay, so let's write the formula first. Okay, so variables which we have in this problem. We have F, which stands for force. We talking about area. That will be A. And we have V, which represents speed of the wind. And of course, you always have that constant of proportionality. Okay, so let's build the formula for the problem. So they talking about force equal, and I always put in constant after the beginning, so I won't forget about it because you need to have a constant. Let's go back to the problem and read it. F, the force of the wind, varies jointly, so I know it's only product here, with the area, so 8 times square of the speed, so that will be 8 times v to a second power. So the formula will be constant, varies jointly with area, and speed square, which is to a second power. So that's going to be the formula which we're going to use. Of course, we need to find k using info. So the second sentence in the problem will give you the information to find k. Okay, so let's go back to the second part. So we know the wind of 30 miles per hour blowing on the window measure 4 feet by 5 feet. So don't forget that we need the area of the window. So those information will help us to find the area of the window, which will be 4 times 5, which will be 20 square feet, has a force of 150 pounds. So we know F is equal 150. Area of the window is 4 by 5, so we'll multiply, that will be 20. And we know that the speed of the wind it's 30. So let's use that information to find k. So which info I'm going to use? I know that the window was 4 by 5. Okay. So I can quickly figure out what is the area of the window by multiplying 4 times 5, which is 20. Okay. So this is A. Now, force of the wind, the units of force, it's pounds. So they gave you 150 pounds. So just remember, if you struggle, force, it's like a weight. The units are pounds. So we know force is equal 150. And we know V, the speed of the wind, was given by 30 miles per hour. Okay, so let's substitute. So we have F, which is 150, equal constant times area, which is 20, times V to a second power. So we have 150, it's equal K times 20 times 30 to a second power. So from the left side, we'll end up with 18,000. And we're just going to divide each by 18,000. And that will give us that the constant of proportionality, let's reduce that fraction, cross the zeros, then 15 and 1,800, you can reduce it, that will give you 120. Divide each by 15, so you're getting 1, and here you'll get 120. So the constant of proportionality is 1 over 120. Again, you can keep it most likely as decimal also. So this is constant of proportionality. So our formula is K, which is 1 over 120 times area times speed to a second power. So this is the formula for this problem. This is how we calculate the force of the wind. Now, let's go back and let's see what we need to find. So the last question of the problems tells you what we need to find. So we need to find F, what force does a wind of 50 miles per hour, so we know V, which is the speed of the wind, which is 50 miles per hour, extract on the window, which measured 3 by 4. So they not give you the area because area is our variable. However, they give you the dimension of the window, which is 3 by 4. So the area of the window will be 12 square feet. So we need to find the force of the wind when the speed of the wind is 50 miles per hour and the area of the window is 20 square feet. Okay, so we need to find F if, again, area of the window, that was 3 by 4, so that was window. If area it's equal 12 square feet. Okay, so area was given and the speed of the wind was also given, which was 50. That was 50. Let me just go back quickly. 50 miles per hour. Okay, so we're going to use that formula to find the force. It's equal 1 over 120, constant of proportionality, times area, which is 12, times 50. Don't forget that we need to square that speed of the wind. Evaluate that, and that will give you 250. And since we're talking about force, the units of force is pounds. So that's the answer. Okay. Okay. And I have one more for you guys to solve it. Okay, so next one I'm going to solve number 41. So I'm trying to give you a lot of info. I'm going to solve problem 41 from page 193. And this problem, it's also on the PowerPoint, so you don't need to actually log into ebook. So here, this is the last power about the horsepower. Okay, don't worry, ladies. Okay, you don't really need to know too much about horsepower. I'm sorry, not ladies, but anybody who's not feel comfortable about horsepower. We just need to use our algebra skills to solve that problem. Okay, so it's not so bad. The horsepower. So I will introduce the variable. My first variable will be horsepower. I'm going to label that with H. That the shaft can safely transmit varies jointly So I'm going to have more than two variables, excuse me, and just multiplication because of jumping. With its speed, the speed is revolution per minute, Silk Road speed. So we have a speed, that's why the units are RPM, which stands for revolution per minute. With its speed, so speed will be my second variable, and the cube of the diameter. Okay, the diameter of the circle, so D will be then my second variable, which is diameter. So I'm going to use the first sentence to build the formula which we need to solve that problem. So we need to build the formula for horsepower. The first variable is horsepower, so H equal varies jointly, so constant, because we always need constant. And I already know that we only have a multiplication with its speed, so it's going to be K times S and times D will stand for diameter, but we're talking about cube of diameter, so it will be D to the third power. So let me write this down. So our variables, which we have, H will stand for horsepower, S will be speed, and D will be diameter. Okay. 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 And of course, we have constant of proportionality, and that's not the variable. We have to find it. Constant of proportionality. So let's build the formula. Horsepower equal constant of proportionality. And going back to the problem, they mention that horsepowers varies jointly, so equal K, which is constant of proportionality, times speed, which is S, times D, which is the diameter, but don't forget cube of diameter, so D to the third power. So this is the formula which we're going to use. Don't forget that we need to find so we need to find K. So go back to the problem now. Let's see. So we know if a shaft of a certain material, 2 inches in diameter, so D is equal to inches, can transmit 36 horsepower. We know horsepower, it's 36. At 75 revolution per minute. So 75 revolution per minute, that's the speed. That's the speed. So let's use this information. Don't even read the last part. Let's use this information right here to find K. D is equal to, H is equal 36, S is equal 75. Let's substitute them from into equation to find what is K equal. Before we solve the problem, we always need to find that constant of proportionality. So use the info using that H horsepower. It's equal 36. I'm going to skip units, guys. Okay, let's just put it that way. Okay, 36. Now the speed was equal 75 revolution per minute, and the diameter was equal to, I think, inches. Yeah, 2 inches. Okay, so let's substitute. So we have 36 equal K times S, which is 75 times D, which is D to the third power. And we're going to solve for K, so we have 36, it's equal A times 75, which will give us 300. So 2 times 2, it's 4 times 2, it's 8. So we have 8 times 75. So we have 600. So we have 36, it's equal K times 600. Okay. And now to find K, we're just dividing each by 600. And we have K, it's equal 36 divided by 600, which is, let me just change that to decimal, 0.06. Okay, so if we want to have that as a fraction, that will be 6 over 100. Can divide each by 2. So that will be 3 over 15. Okay, if you want to keep it as a fraction, that K will be 3 over 15. Okay, let me just keep it as a fraction. So the formula will be H, it's equal 3 over 50 times S times D to the third power. Okay, so that's the formula for this problem. We find K, and let's go back to the problem. Let's see what we need to find it. So here they asking what diameter, so we need to find D, must be shaft have in order to transmit 45 horsepower. So horsepower is equal 45 at 125 revolution per minute. So the speed, circular speed, it's 125. So we need to find the D when H is equal 45 and S is equal 125. Okay, so find diameter, which is D, if horsepower it's equal 45 and speed was equal 125. Yeah. 125 revolution per minute. And that's it. Okay, so let's substitute. We're replacing H with 45, constant 3 over 50 times S, which is 125 times D to the third power. Okay, so let's simplify. So we have 45, it's equal 3 times 125 divided by 50 times D to the third power. 3 times 125, 375. So we have 45, it's equal 375 over 50 D to the third power. Okay, so I will just change that to decimal. 375 over 50, let's change that. This is the same as 7.5. So 45 is equals 7.5 D to the third power. You need to solve for D, so divide both sides by 7.5. So 45 divided by 7.5, we're getting 6 equal D to the third power. And since you have to find D, so we will take the cube root of both sides, because cube root and the third power undo each other. So that will give us that D, it's equal cube root of 6. Which we're talking about the diameter in inches. So if you will tell somebody that diameter it's equal cube root of 6, they will look at you like crazy a little bit. So let's estimate that. So cube root of 6, the cube root of 6, So make sure that you guys, everybody may have a different calculator, but you know where to find the cube root on your calculator. So cube root of 6, it's about 1.817 inches. Okay, so let's just round it to 1.82 inches. So the diameter is 1.82 inches. Okay, so that's it from all of the problems from section 2.5. So 2.5, that's the only section which has the word problems. I went over many word problems. Hopefully that will help you with the homework and eventually later study for a test, which we will have next week. So don't forget 2.5, important section. We talk about direct variation, which is only two variables, which they are proportional to each other. And any type of the variation, you always have a constant. Then we talk about inverse variation. That's the division. Inverse means division. So you have y equal constant divided by x. Inverse variation, just two variables. And then we start mixing them together. So joint variation, okay, that's when we have more than two variables and the formula has only multiplication. So of course you have k and you multiply more than two variables together. Combined variation, that's when you have mix of direct and inverse variation. So you may see a multiplication division of more than two variables. Just remember that each of the variation has to have a constant in front of everything. So don't forget about that constant. And just remember the only time when you build the fraction bar, when you have a division, it's when you see the word inverse. That's the only time when you build that division, the fraction bar. So the fraction bar in each formula, that's when we hear that word inverse. Okay, so in those type of problems, when you hear inversely, that means, okay, it's time to put the fraction bar. The rest, it's always multiplication. So hopefully I was able to explain those problems clearly to you guys. I definitely recommend it to check them out. Okay, thank you so much for watching.